So now we're going to talk about the bathtub problem, and you should have taken your time, pulled the bathtub problem off your materials list, and tried to work it on your own. I'm just going to be going over the answers. So you pull out the plug from the bathtub. After 40 seconds, there are 13 gallons of water left in the tub. 1 minute, so after 1 minute, there are 10 gallons. Assume the number of gallons varies linearly with the time since the plug was pulled. So first thing that I look at is I've got minute and seconds, and we have to have the same units. So I know 1 minute is the same thing as 60 seconds. So we want to write the particular equation expressing the number of gallons, G, left in the tub in terms of the number of seconds, S, since you pulled the plug. So G in terms of S is the same thing as Y in terms of X. So X is seconds, Y is the number of gallons. So my two ordered pairs are 40-13 and 60-10. So I find my slope. And it's negative 320. I plug in a point. I plugged in 60-10. Found out that B was 19. And then I write my slope into Y equals mx plus B form, or slope-intercept form. And I write my B in. How many gallons would be left after 20 seconds? So all this is evaluating functions. We did it in the first unit, and we're using it again. We take the equation that we got here, and we're going to plug in 20 seconds. When you plug in 20, you get negative 3 plus 19. There's 16 gallons left. So if I wrote this as an ordered pair, it would be, what is it again? X is our seconds, Y is gallons. So 20, 16. Okay? With 50 seconds, we're evaluating. That's the same thing as saying f of 50. What is the function evaluated at 50? Negative 320 times 50 plus 19 is negative 7.5 plus 19. That means there's 11.5 gallons. So if we wanted to write the ordered pair, when X is 50, Y is 11.5. At what time will there be 7 gallons left? Gallons is my Y value. So that's 7 Y value equals same equation. I just did a decimal. And now we're solving for X. So we subtract 19 from each side, divide by negative 0.15, and we get 80 seconds. So when my X is 80, my output will be 7. Find the y-intercept. Okay, so the y-intercept. The y-intercept is when our X is 0. So we look at our equation. This one's pretty simple if you have your equation. Where is it when X is 0? It's just your y-intercept. It's 19. So what does this number represent? Well, this is seconds. This is gallons. So at 0 seconds from pulling the stopper, I had 19. That's the number of gallons when the plug is initially pulled. Okay? We want to find x-intercept. X represents our time. What does the number represent in the real world? So our x-intercept is when our y is 0. So when our y is 0, that's gallons. When there's 0 gallons left in the tub. So you input 0 for y and solve for x. You're using, again, the same equation. Negative 3 over 20 x plus 19 So you're going to put 0 in for Y. And you get 126.67 equals X. Okay, so your X is what? Seconds. So that's the number of seconds it takes to empty the bathtub. You pull the, what is the slope? It was -3 over 20. If we do the decimal, it's going to be -0.15. That means -0.15 every 1 second that goes by. It goes down 0.15 gallons. Or every 20 seconds, the water goes down 3 gallons. Remember that this is my change in Y over change in X. What does my Y represent? The Y is the gallons. What does the X represent? The seconds. So it goes down 3 gallons every 20 seconds. So the only other assignment that you have for today is to review for your test, and your test is on Wednesday. You need to be able to create and solve one variable linear equations, create and solve two variable linear equations. You need to be able to go from standard form to slope-intercept form. You need to be able to graph a linear function if I give it to you in slope-intercept form or standard form. You need to be able to find the slope or the rate of change from multiple representations. You need to be able to find an equation from multiple representations. You need to find the domain in the context of the problem. You need to be able to find the x-intercepts and the y-intercepts. And you need to be able to interpret the rate of change in the context of the problem. You need to recognize that a linear constant relationship in a real life situation. So your test will be tomorrow. A line goes through 0, 0 and has a slope of 3. Select all of the points that are on the line. The line goes through 0, 0 and has a slope of 3. We want to select all of the points that are on the line. So if it has a slope of 3, goes through 0, 0, it's y equals 3x plus your y-intercept. Well, your y-intercept is when your x is 0. It's 0, so we don't have to put anything here. So let's plug this in. -1. -1 times 3 is -3. That means that, yes, that is on the line. 3 times 1 is 3. Yes, that is on the line. 3 times 3, I'm just putting this into the equation. 3 times 3 is 9. That's not 1, so it's not on the line. 3 times 1 is not -3, so it's not on the line. -3 times 3 is -9. It's not -1, so that's not on the line. Which answer best describes the slope of the graph above? As the distance traveled increased by 20 miles, the amount of gas in the tank decreases by 3 gallons. Let's first find the slope. So y2 minus y1, and our y represents gas in gallons. x2 minus x1, and that is miles. And so when you reduce it, you're going to get 3 over 20. So it's going to be decrease 3 gallons for every 20 miles. That's what we're going to. Distance traveled increases 20 miles. That's positive. The amount of gas in the tank decreases by 3 gallons. That's right. Decrease. Well, the distance we traveled doesn't decrease, it increases. As the distance traveled increases by 30 miles, it didn't increase by 30 miles. As the distance traveled decreased by 3 miles, that's not correct. Okay?